In this video, we're going to work on a special technique for graphing lines. This is using what is known as the slope and the intercept. Now, in order for this to work out nicely, first we have to introduce how to find the slope when you have just a couple of points, and how you can find the slope if we actually have the equation of a line. So let's begin with just a little bit of vocabulary. A function whose graph forms a straight line is known as a linear function. Okay, pretty straightforward. Now, when looking at the equation of that line, it could come in a few different forms. It could be written in either standard form, slope-intercept form, or point-slope form. Later on in some different videos, we'll explain each of these other different forms and kind of why each of them is useful. Before getting to any of these forms of a line, we have to know about one very important fundamental property for lines, and this is known as its slope. In a nutshell, you can describe slope as a measure of the steepness of a line. So, if you're looking at just any old two lines and you want to tell them apart, you can describe which one is steeper than the other by using this measure known as slope. Now, how you describe slope or actually attach a quantity to this thing called steepness is usually done through a formula like this. This says if you know 2 points on the line, call them x1 and y1 and x2 and y2, so 2 different points, you can figure out how steep that line is by subtracting the y-coordinates and dividing it by subtracting the x-coordinates. Now, if you're not quite familiar with that formula, that's okay. It's definitely one you want to memorize and have in your back pocket, but you've probably more commonly seen, say, slope known as rise over run, and it's really the same thing. When you're subtracting the y-coordinates of the points, this gives you how much the line is rising, and when you subtract the x-coordinates, it's giving you the run of that line. So again, subtract the y's, that's the rise, and subtract the x's, that's the run. On a side note, something that you want to keep in mind is that when you do this formula, it may turn out to be positive or negative. Now, if it ever is negative, I recommend most of the time just giving that negative sign to the top of the fraction. If it is negative, your rise will go down first, and then you'll take care of the run part, usually going right. And if it's positive, you'll take care of the rise part going up, and then going to the right. So again, just something to keep in mind when getting to graph. Be very, very careful when you are using this formula for the slope of a line. Do not mix up the coordinates. In other words, you want to subtract y1 from y2 and subtract x1 from x2. Keep them in that order. Also, pay very close attention to, say, the negative signs that may come up in that subtraction process. And lastly, be on the watch out for some special cases. Near the end of this video, we'll highlight some special lines that may not even need the slope formula. Now, when you go through computing the different steepness of lines, you're probably going to fall into one of these 4 categories. Either your line goes up, your line goes down, or it doesn't go anywhere, it stays constant, or the line is completely up and down. The way you can recognize each of these cases and how they relate to their slope is actually by the sign. For example, in that first case, that's an example of having a positive slope. So, the number that you get when taking care of the formula will be some positive number. If your line is going down, that's an example of a negative slope. The last 2 cases are basically our special cases. If it turns out that the line is constant, completely horizontal, then the slope will be 0. However, if the line is completely up and down, in that case, we say that it does not have a slope, or that the slope is undefined. Now, these are the only 4 cases that it could fall into, and so we'll look at in a bit how to recognize them when going through this algebraically. So let's look at our first example here. I basically have 2 points on a line. One is -2, 4, and the other one is -1, -1. And I want to figure out what is the slope through these 2 points. Well, the first thing I'm going to do is basically bring up my formula for the slope. And here's how you can kind of interpret it. We're going to take the y-coordinate of the second point and subtract the y-coordinate of the first point. Then we'll divide it by the x-coordinate of the second point minus the x-coordinate of the first point. Okay? So it sounds kind of complicated. Let's go ahead and plug it in. So you can see I have my y2 minus y1 divided by x2 minus x1. And I basically put everything in parentheses like that so I could keep extra careful where my signs were going. All right, so basically I want to take this and simplify it, and then I'll have my slope. So let's start off with the top. If I have negative 1 minus 4, that'll give me a negative 5. Meanwhile, on the bottom, if I'm subtracting a negative number, that's going to change it to addition. So negative 1 plus 2. Okay, looks pretty good. Let's take it a little bit farther. Negative 1 plus 2 gives me a positive 1. Therefore, I have negative 5 over 1. And so, completely simplified, I get that my slope is negative 5. Okay? Therefore, I can backtrack and say at the very beginning that the slope of the line through these two particular points is negative 5. Visually in your mind, you should picture that the line is going down from left to right. All right, let's look at another quick example. Here I have 2 points through a line, and I have 3, negative 4, and 3, 5. And again, I want to figure out what is the slope of that line. Well, just like before, I'm going to start off with the formula. So take the y-coordinate from the second point, subtract the y-coordinate from the first point, divided by the x-coordinate from the second point, minus the x-coordinate of the first point. Okay, so plugging all of those in, I have 5 minus a negative 4 on top, and 3 minus a 3 on the bottom. Let's start to simplify. When you subtract a negative, that gives us addition. So 5 plus 4 gives us a 9. Meanwhile, on the bottom, 3 minus 3 is equal to 0. Uh-oh, looks like this one has a bit of a problem. We can't divide by 0. So what do we do with 9 divided by 0? Well, this is one of those special cases that I mentioned earlier. We don't get a slope. Since we're not allowed to divide by 0, I can consider this slope as basically undefined. And visually, I should get the sense that this line goes straight up and down. In fact, if you examine the 2 points I started with, that's exactly what's going on. They both have exactly the same x-coordinate. Now that we know a lot about slope, we can start talking about one of those forms of a line. And this is known as slope-intercept form. This form can be described as y equals mx plus b. And when a line is written in this form, it's really useful for graphing it out. This is because the m represented in that formula represents the slope, and the b represents the y-intercept. Now, here's why this form is especially useful for graphing. When graphing, and it's in this form, you think of that y-intercept as some sort of starting point on the y-axis. Okay, so you literally start at that point. Then you use the slope as directions on how to get to another point on the line. So you use that concept of rise and run to essentially find another spot. Now, this will give you 2 places, your starting point and that new point you moved out to. And you'll draw your line through those 2 points. So let's try graphing one of these out. Let's try graphing f of x equals 3/4 x minus 5. And notice how this is definitely in slope-intercept form. So the 3/4 represents our slope, and the minus 5 is our y-intercept. So in order to graph this out, I'm going to start with that y-intercept. So the first point I'm going to put on my graph, I'm going to put right at negative 5 on the y-axis. Okay, so that'll be my point number 1. Now to find my second point on this graph, I'll move from that point up 3 units and to the right 4 units. Okay, so again, imagine going up 3 and to the right 4. This will put you at another point. Well, now that we have 2 points, we can draw our line through them and get a good sense as to what this linear function looks like. All right, see, that's not so bad. Let's give this another try with a different example. Here I have y equals negative 2x plus 3. And again, this is in slope-intercept form. Our slope is negative 2, and our y-intercept is 3. So let's start with that y-intercept and put a point right on the y-axis where y is equal to 3. Now from this point, I want to go down 2 units and then to the right 1. Now, the reason why I'm going down is because we have a negative slope here. So down 2 units and to the right 1. This will give us a second point on our graph. Well, just like before, go ahead and draw a line between those 2 points, and then we have our line. As I mentioned before, every line or form of a line has its own usefulness. The other form of a line is standard form, and you can recognize it as ax plus by equals c. So we basically have numbers in front of x and y are both on the same side. Now this form here is really good for graphing when you want to use the intercepts. And recall that if you want to find the x-intercept, then you basically plug in a 0 for y. When you want to find the y-intercept, you plug in a 0 for x. And once you have those 2 points, then you can draw your line through it and you can see what the line looks like. At this point, you might be asking yourself, well, what form of the line should I use? For example, what if I have something in slope-intercept form and I want to use the intercepts to graph it like when it's in standard form? Or what if something's in standard form and I want to graph it like slope-intercept form? Well, the good news is you can switch back and forth between these two forms. And this is basically how you do it. If you want your equation in slope-intercept form, then you basically end up solving it for y. So get that y all alone. If you want it in standard form, well then that requires a little bit more work, but it can be done. To write an equation in standard form, get both of your variables on the same side. Make sure that the constant term, that's the one without any x's or y's, is on the other side. Then clear out any fractions by multiplying by a common denominator. And lastly, check your x term to make sure it's positive. If it's not, multiply through by a negative number so that it is positive. Again, that's quite a little bit of work to get it in standard form, but most of that is just so it's in its technical definition for standard form. Let's take a couple of examples to see how this works out in practice. On the left, I have a line written in standard form, and I'm going to change it into slope-intercept form. With the example on the right, this is in slope-intercept form, and we'll see how it gets changed into standard form. All right, so let's begin. With one on the left, since we want this in slope-intercept form, we basically want to solve it for y. So let's get y all alone. To start this process, first subtract a 7x from both sides. This will give you 2y equals 14 minus 7x. All right, that looks pretty good. Now y is not completely all alone, so let's go ahead and divide everything by 2. This will give us y equals 7 minus 7 halves x. All right, that's definitely pretty good. Now, if you want to change it to where it looks exactly like slope-intercept form, then you probably just want to relocate the location of your x and the 7. So, just kind of swap their location. This will give you that y equals a negative 7 halves x plus 7. And now you can clearly see that the slope is a negative 7 halves and the y-intercept is a positive 7. All right, let's take a look at our next example. With this one, we want to put it into standard form. And to begin that process, I'm going to multiply everything through by 2. This will get rid of my fractions. So 2y equals x plus 6. All right, that looks pretty good. Now I want to get both my x and y on the same side. And in order to do this, I'm going to subtract 2y from both sides and subtract a 6 from both sides. So the result will be negative 6 equals x minus 2y. All right, perfect. Now, to make it look exactly like standard form, I'll put my variables on the left side and the negative 6 on the right side, just so it fits that template a little bit better. So x minus 2y equals negative 6. And now it is in standard form. So if I wanted to graph using the intercepts, I could do that very quickly. Now that you can graph a line when it's in slope-intercept form, when it's in standard form, and you can switch back and forth between those two forms, let's talk about some very special cases. Remember the line that went straight up and down and the line that went horizontal? Those are two very special cases. To recognize a horizontal line, its equation is y equals some number. Now, basically what's going on there is since your slope is 0, it eliminates the x. So you just have y equals number. Now, a good way to remember that this definitely gives you a horizontal line is that no matter what point you choose on that line, the y value will always be the same number. Now, the other special case is, of course, the vertical line, the one that goes straight up and down. You can recognize its equation because its x equals a number. And again, a good way to remember this one is that no matter where you are on the vertical line, that the x value will always be the same number. Let's take one of these special examples and graph it out. So here I have y equals 5, and I want to see what it looks like on my graph. Well, recall that this is a special case of a horizontal line. So what I'm going to do is basically draw a horizontal line right at 5, just like that. Now, again, to double check that this is really good, imagine taking some sort of point on the line and notice how its y value is 5. In fact, no matter where you choose a point on this line, the y value will always be 5. So that looks pretty good. Let's do another one. Okay, here's my other special case, x equals -2. The way I'm going to graph this one out is I'm going to put a vertical line right at -2, so straight up and down. And again, imagine taking points on this line. No matter where you take those points, the x value will always be a -2.